Okay, so we are going to work on showing our work and organizing it a specific way. So on this first two-step equation, you're always going to draw a line down the equal sign because you're trying to keep your equation balanced between the left side and the right side. All right, so first you're going to look at your problem and look for that variable. And the variable is over here on the left-hand side. What is happening to the variable is we're multiplying by 8 and we're adding 2. Okay, so we need to do the inverse operations. First, we're going to remove this constant by doing the opposite of addition. So we're going to show that we're subtracting 2. And what we do to one side, we have to show on the other side also. Okay, so when we do that, that's one step, so we're going to draw a line across. To complete this step, we're going to show that positive 2 and negative 2 eliminate, okay? They add to 0. The only thing left on the left-hand side is 8 times x, so we're going to bring that down. And it's still set equal to this other side. Now we're going to simplify this other side. What's 18 minus 2? 16. So now we have a one-step equation, and we've been working on one-step equations in our warm-ups each day. So this is just multiplication that's happening to the variable. What's the inverse operation? Division. So it's being multiplied by 8. We're going to do the inverse and divide by 8. We're going to show that on both sides. Now we are showing these as fraction bars. It's going to keep our work aligned vertically. Okay, so 8 divided by 8, it eliminates to 1, and 1 times x is just x. So that was one step. So I have x left over. Our goal for solving equations to isolate the variable, right? Which means get the x alone. And 16 divided by 8 is 2. And so this is our final answer. You're going to want to go back and test your answer. You're going to check your answer. So put 2 back in for x. 8 times 2 is 16. 16 plus 2 is 18. And that's true. We do have 18 on the other side. So we know that this one works. So whenever you do this next assignment, you need to show your work vertically like this, step by step. I want to see those inverse operations. Okay, so let's look at number 2. Number 2 is slightly different. The only difference is that we have subtraction on this side, right? So instead of using subtraction as our inverse, now we're going to be using addition as our inverse. So draw your line down the equal sign first to separate your sides. We have 6 times x minus 3. We're going to get rid of the constant first. The constant is the value that does not have a variable. We're always working on the side that has the variable. Okay, so the inverse operation of subtracting 3 is to add 3, and that's one step, so we're going to draw our line. These are opposites, so they cancel out to 0. Bring down the term that's left over, 6 times x. And 15 plus 3 is 18. Okay. So now we have another step to perform. The inverse operation of multiplying by 6 is to divide by 6. Okay, so 6 divided by 6 is 1. 1 times x is just x. 18 divided by 6 is 3. So x equals 3. Put 3 back in and check your answer. 6 times 3 is 18. 18 minus 3 is, and we have 15 on the other side, so that's true. Okay. Let's look at number 3. Number 3 is just switched where the variable term is on the right-hand side. So now instead of working everything from the left, we're doing all of our inverses from the right. It does not change anything except for where we're writing our inverse operations. So go ahead, draw your line vertically down your paper to separate the left from the right. And this is saying 6 times x minus 2. So we're going to get rid of this minus 2 first. So the opposite of subtracting 2 would be adding 2. So do that to both sides. Inverse operations cancel 0. 6 times x is left over, so bring it down. 10 plus 2 is 12. Okay, so now we have one last step. This is being multiplied by 6, so the inverse operation would be to divide by 6. Remember, fraction bars mean division. 6 over 6 is 1. 1 times x is just x. I drew my line because that's a step. X is by itself. That was our goal. 12 divided by 6 is 2. So this is our final solution. Place 2 back into this problem and check it to make sure that it is equal to 10. So 6 times 2 is 12, minus 2 is 10. So it is right. Okay. Number 4 was chosen because it has that division in it. Okay, we still go through the exact same process. Draw your line vertically down your paper to separate left from right. This x is being divided by 6, and then we're adding 8. Okay, so we're going to work this backwards. The inverse operation of adding 8, subtracting 8. We have to eliminate our constant before we work with our variable. We're always going to get rid of this number first before we go to our variable. These cancel because they're inverse operations. So x over 6, or x divided by 6, is left over. 10 minus 8 is 2. Okay, what is the inverse operation of dividing by 6? Okay, so we are going to show that we're multiplying by 6 on both sides. When we divide by 6 and multiply by 6, they undo each other. They're inverses, so they cancel to 1. And 1 times x is just x. And 2 times 6 is 12. You're going to want to go take that and put it back into your equation. 12 divided by 6 is 2. 2 plus 8 is 10. So that's true. Okay. Number 5 still has division. It looks a little different because we have an entire numerator being divided by a denominator. Earlier I said whatever value is by itself, the constant, we have to take care of that first before we do anything with our variable. Okay. But in this case, this entire top section belongs together, the numerator, and the entire thing is being divided by 3. Okay, we still draw our vertical line down our equal sign. Okay, and so you can't separate these apart because they're both being divided by 3. So what's the inverse operation of dividing by 3? So just multiply both sides by 3. And so when we multiply the opposites, these are going to cancel to 1. And so we have x minus 11 left over. So that freed up our numerator now. And 11 times 3 is 33. Okay, so now let's go back over to our variable. So we just have our variable minus 11. So what's the inverse operation of subtracting? So we're adding 11 to both sides. These are going to cancel. X is left over. That was our goal, to isolate x. 33 plus 11, 44. So that should be our final answer. Take 44 and put it back in and check it. 44 minus 11, 33. 33 divided by 3 is 11. And you see we have 11 on the other side. So we know that that's correct. Okay, for number 6, we need to draw our line down our equal sign. Okay, what's different about this one is that we have variables on both sides. Okay, we can't isolate a variable unless that variable is already on one side. So we're going to need to move one variable to the other side. Whenever it switches sides, it changes signs. okay? It's just like inverse operation. So we need to move that 5t over here to 8t. But once it crosses over this boundary, it's going to become its opposite sign. So if I'm removing this and placing it over here because they're like terms, instead of adding 5t, it becomes minus 5t or negative 5t. So then bring 21 down. And 8t minus 5t is 3t. And then, okay, so the variable is over here. What's happening? What operation is happening here between 3 and t? It's multiplication. When you have a coefficient with a variable, it's multiplication. So 3 times t. The inverse operation would be to divide by 3 on both sides. 3 over 3 is 1, and 1 times t is just t. 21 divided by 3 is 7. Okay, so now we would check that. Let's go back to the original equation. You can put 7 in for t on both sides and simplify. What is 7 times 8?
56.
Okay, so this equals 56 on this side. So whenever I work this one out, it should be equal to 56 also, right? So what is 5 times 7? 35 plus 21. It's also 56. So we know that these are equal to each other. We go back to the original equation because there is a possibility we are human. We may make mistakes. Some people may ask, well, can't you just go back to this part of the equation? You could, assuming that you didn't make any mistakes at all. It's just a fail-safe if you go back to that original equation. Okay, so whenever you do the two-step equations assignment today for practice, you need to be showing your work this way. If you are just showing me answers, you're not following directions. So I'm going to need you to go back in. If you did go through and answer them, that's fine. But I want you to go back in and show these inverse operations step by step in this format. Okay?